So it looks like there's an AI company that's trying to bring autonomy to software engineering. It automates and optimizes the entire development lifecycle with autonomous AI powered system called droids.
As AI takes over, make this your mantra. Let the robots do the work. Subscribe to stay on top of AI news.
So all the way from idea to research to communications to delegations to coding and documenting, testing and reviewing, everything from beginning to end is done autonomously through these AI agents. Droids help organizations systematically ideate, plan features, write code, write tests, review code, and write documentation. So it starts with coding. They can delegate tedious and repetitive development tasks like migrations, refactors, and integrations. So all the simple and not so simple tasks that are repetitive and boring, you would be able to automate them by assigning droids to complete them as part of that development process. So we've seen something similar with, for example, DEVIN, that's able to do autonomous software development to a degree. This new company, by the way, called Factory AI, is taking it to the next level and looks like at least initially doing it mostly for enterprise level companies to allow them to fully plug into the system that utilizes droids at every step of the life cycle to develop applications. It's able to do testing, save engineering hours with automated unit test generation, with iteration based on test execution. It's able to auto-generate test cases, analyzes code-based gaps, and automatically generates unit tests to maximize code robustness and coverage. We've seen a few papers where GPT-4, for example, can come up with fairly good unit tests. The unit tests, for those that are not familiar, are basically, imagine if you have a whole bunch of code. What it does is it picks little specific kind of units of code from within it. So for example, a little function that does one particular thing. So for example, if you click the add to cart button, it adds whatever number of products, whatever number of units that you've selected, it adds it to the cart. Well, a unit test might take just that little block of code and figure out, okay, how well does it work if we put 9 trillion units into it, right? If we just max it out, what happens if we put a decimal? What happens if we put 0? What happens if we put a negative number? What happens if we put the letter A, right? Does that break the system? Does it cause weird bugs to happen, etc.? Of course, humans can do this pretty well, but it is, it's a cognitive load. You got to sit there and think about some specific cases. You got to run each of those cases through that unit test, etc. It's important work, but it's pretty boring. And when people get bored, we tend to make mistakes. So it's one of those things where having AI automate that tasks is definitely kind of a big deal. Next, we have code review. So for example, when you're using something like GitHub, if you're working in a team to develop code where there's multiple people contributing to that code, you have various managers and people that are looking it over. AI can be really helpful in finding out certain mistakes that happen, right? So it can do automated pull request descriptions, right? So if you're adding something new, it will briefly kind of help you describe what the heck it is that you're trying to add. It can summarize what's been happening. The AI droids are also able to do bug fixing and what they call CI self-healing. So CI is continuous development. So similar to what we talked about where multiple contributors are contributing to the code, there's different managers and supervisors and reviewers kind of going over that code. There's continuous development on that code. So that's CI, and CI self-healing are things like, for example, automated rollbacks. So if something screws up and it gets noticed, the code will automatically roll back to the previous version that is known to be stable and working just fine, as well as all sorts of other things like handling resource management, dependency management. You're sort of allowing that continuous integration process to run smoothly. Which again, if you think about it as just a whole bunch of AI droids, as they call them, right? As different droids are adding to the code, adding to the project, there's another droid or a handful of droids that are making sure that everything's correct. And yet another set of droids that are making sure the whole system doesn't fly off the rails, if you will. They're making sure everything's stable and jump in as needed to prevent, for example, a new version causing failures. The AI droids also work at the top level to manage and push forward the project. You're able to speed up project planning with automated ticket descriptions, subtask creation, and scoping. By the way, I gotta say, if you've ever had a to-do list that was just overflowing with stuff, right? You had your high priority, low priority, someday maybe. There does exist a million different approaches to how to do that. You have the get things done approach. And I mean, there's a million different ones, not just for coding, but just for your regular to-do list management. And I got to say, a lot of us, especially if we struggle with, decision making like this, it would be helpful to have an automated AI solution that knows exactly what you're trying to do, that kind of selects the best tasks for you to work next. So you spend an hour loading up all your tasks into it, kind of describing what you're trying to achieve, but then you no longer have to look at the entire to-do list. You don't have to keep up with things like Asana, where it shows you kind of like what you have to do day by day or whatever. Once you load everything up, you just get shown the next best thing that you must work at, that you must complete. You can change how they prioritize things, but I gotta say, just something like this, not just for coding, but for anything really, for any to-do list, for any project management list, having something that intelligently picks the next best item, I gotta say, could be very useful. And next, we have the knowledge base. So save time in communication and knowledge sharing across your engineering organization. So basically, as you're doing stuff, it creates your entire sort of documentation database, engineering systems, Q&A, knowledge reports. Have you ever tried to figure out how a new piece of software worked? You run into some issue, you go online to their website to figure out if they have that documentation, and either A, they have none, or B, they have one, but it hasn't been updated, so what it says just makes no sense. It's a completely different UI or a different system that they're using now, making that documentation basically useless. Now imagine that entire database, all that documentation and manuals and frequently asked questions being kept up to date to the minute, to the second perhaps, and also completely automated by these AI droids. The second something changes, they go to work in rewriting that documentation to make sure it's up to date. And of course, this applies to both internal and external documentation. Here they're actually talking about, monitor the code base, modify documentation weekly to reflect changes, various automated code base diagrams, etc. As I'm reading this, I'm really can't help but wonder how useful would this be to every other business there is, not just software development. I think Ethan Mollick was the one that kind of mentioned this idea. Fortunately, I don't remember who exactly said this. I think it was him. But this idea that the people that are working on AI, they tend to be coders. They tend to be developers. So that means that they're working on automating coding more than anything else, right? Because that's their kind of bread and butter. That's what they can apply AI to with the least amount of friction. But those sort of AI researchers and people working on AI, they might not know, for example, architecture or accounting. So what happens is that our ability to automate coding with AI is progressing much, much faster than automating accounting and architecture and project management and all that other stuff, even though it's obvious that this is going to be extremely useful across the board. There are other areas where these progress is taking place at a rapid pace because the money behind it is huge. So for example, in the finance space or in the medical space, right? There's a lot of incentives to add AI to those fields because of the sheer amount of money that's involved. But imagine something like this, but for your taxes, right? It starts out by going through all your accounts and collecting every single transaction that you've had, scanning all the physical receipts, doing bookkeeping in its entirety, right? Going through and just creating beautiful charts and graphs and everything else that you need for your bookkeeping, profit and loss statements, etc., accounts payable, accounts receivable, etc. Then going and searching for the best possible tax deductions and breaks, etc., applying those, finalizing your taxes, and just filing them for you. Maybe even giving you some sort of an insights for what you could do differently next year to save some money. If you've been following this channel for a while, you know that we've seen a lot of research pointing to this as the place where everything is going, the idea of multiple agents working together to create these systems. And the research papers usually point to where the money is heading, where the actual development of real-life products is heading. So when you see people like NVIDIA and Google and Facebook, Meta, etc., publishing papers on how to do X, for example, in this AI space, then, 4 to 6 months later, maybe a year later, you start seeing the products doing X, doing that specific thing, begin to roll out. So it's an important thing to understand this company, right? So this is Factory AI, the machine that builds the machine, which I got to say is pretty cool, I guess. It's taking that idea and it's progressing it forward. But my point here in this channel isn't that this is the company that's going to do it and this is going to be amazing. I don't know. Maybe they'll be the next best thing. Maybe they'll be a flop. Who knows? I don't really necessarily care. But the point is this idea is coming. It's coming fast. And first and foremost, we're going to see it for coding, for software development. And then you'll see the same things rolling out at the enterprise level for medical, finance, probably military applications, although we may or may not hear about it. But then it's going to start hitting all the other industries, all the other spaces. Assume for a second that you have something like this and it's able to be applied to any task that you do, whether in work or school or around the house. And imagine it's effective, and imagine it's getting cheaper and cheaper every single year to where the cost of running something like this isn't just a big deal. Things like this will be applied to pretty much everything. Even think of something as simple as just kind of managing your house. So if you own a house or you're renting, there's probably a number of things that you do around the house, like changing the air filter, paying your bills. If you have, gutters, cleaning the gutters, the drains, whatever. If you're in a cold climate, maybe adding something that prevents icing to the sidewalk, or if you have a garden, adding fertilizer. Imagine something like this, just keeping on top of everything, ordering the air conditioning filter when you need it, reminding you to change it, optimizing your AC use, while at the same time managing, for example, if you own a house, you have some documentation that needs to be there, right? Any repairs that you've made, in case you're selling the house, all the additions, modifications, permits, etc. Managing that whole thing. If you ever decide to sell the house, there's another AI system that, for example, on the buyer side, looks through all the various listings. And if something meets their criteria, reaches out to your AI bot that you can then tell to, go ahead and share this information with them, whatever they need in terms of, yes, we do have a permit for that specific addition to the house. Here it is, signed by the city or whatever. I'm actually not 100% sure how that works, but actually that's kind of the point. In that scenario, I wouldn't need to. What's interesting that I've been noticing the more and more research into AI that I'm doing is that a lot of these companies that are very exciting, a lot of them that in the past, like these tech companies, disproportionately often become unicorns, meaning these billion-dollar plus valuations in the tech space. Very often you hear either Sequoia Capital as one of the backers or A16Z, Andreessen Horowitz. I think DEVIN has a lot of backing by A16Z. So DEVIN is the other autonomous AI coding agent, software developing engineer. Looks like this one is backed by Sequoia Capital. And they're saying today we are excited to announce the latest updates from Factory and the next steps in our mission to bring autonomy to software engineering. Droids are autonomous systems that solve problems for engineers, not just in demos, not just in simple repositories, in complex production settings, testing, debugging, refactoring, migrating, reviewing, documenting. World-class organizations are accelerating their software development with Factory's droids. So again, they're calling themselves Factory AI, and droids are these things that they're using. That's the name that they're using for their little AI agents, which now that I think about it, I'm wondering if droids will catch on more than AI agents. So this is SWE-bench. So it's a sort of benchmark for seeing how well these language models can resolve real-world GitHub issues. So GitHub is this place where a lot of software developers use to share code, to work on projects together. And for a lot of these projects, there's a special section where people say, I have this issue, and other humans in the past have tried to resolve that. So that's the SWE-bench. And right now, it does look like the Factory Code Droid is sitting at the #1 position. It's not open source. It hasn't been verified yet, but that's probably because it's still so very new. So the SWE-bench is an evaluation framework consisting of, let's say, 2,300 software engineering problems drawn from real GitHub issues and corresponding pull requests across 12 popular Python repositories. The reason why this is a good test, a good benchmark, is that resolving these issues frequently requires understanding and coordinating changes across multiple functions, classes, and even files simultaneously, calling for models to interact with execution environments, process extremely long context, and perform complex reasoning that goes far beyond your traditional code generation tasks. This is important, right? Process extremely long context is very important, of course, because, if you think about it, if you've ever tried to solve a problem, complex problem, whether in coding or elsewhere, very often you had to read a bunch of stuff, right? Maybe read or listen to a podcast or some videos, right? Whether that's repairing something around the house or coding or whatever. If you don't know how to do something, very often step one is to, as they say, RTFM, which of course stands for read the manual. Read the manual. RTFM. You can guess what the F stands for. Then we have the idea of performing complex reasoning, right? Because if something's wrong, and let's say we've read all the manuals, the next step is to reason. What is missing? What is wrong? And yeah, certainly that's a lot easier than traditional code generation tasks. The fact that LLMs can spit out code isn't that amazing in and of itself. The fact they can troubleshoot code, the fact that they can give you solutions to various errors that get thrown out when code doesn't work, to me, that was much more exciting when I first started messing around with that, because that certainly seems a lot more human. It's a lot more something that would require reasoning. Just kind of how that evaluation procedure looks for SWE-bench. So you have a certain task here, right? So there's a problem that's written out here. So basically something comes back with an error, right? And that's the input to this language model, SWE llama in this case. And the output we're looking for is a prediction.patch must be applied successfully and produce the same results as corresponding task's instance D for task completion. So this is basically saying we know what result we're looking for, right? We want it to fix the issue. So the question is, can it come up with an output that fixes the issue? And so the SW agent plus GPT-4, the 1106 model, so this is not the GPT-4o model, but the previous best one, it's able to resolve 12.47% of those issues. Factory code droid is able to do 19.27, so call that a fifth of all the issues resolved. Now, by the way, DEVIN from cognition.ai, right, that made a whole bunch of noise when it was first revealed. We don't have open access yet, people. It's slowly rolling out to people, but it was evaluated on the SWE-bench, and it did very well, clocking in at 13.86% of issues resolved. And they're comparing this to GPT-4 at 1.74 to Claude 2 at 4.8. Now, as far as I can tell, the way they used to do these testing, it would just be sort of fed into the LLM without any sort of agentic capability. So it couldn't do loops of reasoning or didn't have any tools. It was just like ChatGPT, right? You ask it a question or you give it some sort of input and it spits out the output. So a lot of people kind of complained that this wasn't a good comparison. So since then, it looks like they kind of changed it up a little bit to where now, if they're trying to test GPT-4, it's not just the LLM, it's the SWE agent plus GPT-4. Or this is Claude 3 Opus and the SWE agent. So these are probably, I would say, much closer to reality in terms of the relative strength of these models. So GPT-4 clocks in at 12.47. Looks like Amazon Q has their own that is better, right? 13.86. App Mapped Navi plus GPT-4o, the Omni model, at 14.60. Again, DEVIN originally clocked in at 13.86. And Factory Code Droid, take this with a grain of salt, right? I'm not saying this is real, but, taking at face value, they are currently the reigning king, if those numbers are accurately, clocking at 19.27. And in the light sort of version of this, where they're only using, I think, a few hundred problems, so it looks like 300 instances versus the almost 2,300 for the main one, it's still sitting at number one with 31% of issues resolved, compared to something like the GPT-4 plus agent at 18%. So it looks like in Bloomberg, they have an article about them saying Sequoia backs AI startup that automates engineering tasks. So it looks like Factory started selling products earlier this year with customers including startups Bubble, Podium, and Stored. And there's more and more of these startups and not quite startups that are joining this market. So we have Poolside AI, Magic AI, and Cognition AI. Cognition is, of course, DEVIN. I think I called them Cognition Labs. I guess it's just Cognition. And so the founder, his name is Matan Greenberg. He was studying string theory for his physics PhD. Now he's a dropout with an AI startup valued at more 100 million by investors such as Sequoia Capital. This is interesting because we're seeing the best and brightest, the smartest people slowly all move more and more towards AI. We've talked about Scott Wu from Cognition AI. We're not going to go over it again, but we're talking about top tier genius people, like the best of the best. So he's a competitive programmer who won 3 gold medals, placing first in 2014 at the International Olympiad in Informatics IOI, right? So Harvard, mathematics, etc. This guy is studying string theory for his physics PhD. No big deal, right? Right? So 70, 80 years ago, where were the best and brightest? Right? Oppenheimer, von Neumann, Feynman, Teller, right? Working on the Manhattan Project, atom bomb, nuclear physics, etc. And then after that, you have people in rocket science, a lot of people going to finance, more recently into tech, software as a service, SaaS. And now the new hot thing is AI. As I was looking through Factory AI's new presentation announcement and kind of how they describe their architecture of how they build it. And again, I'm not here to promote them or convince you that they're going to be the next best thing. I have no clue. My point is simply that a lot of bright minds are all building and thinking about the same thing, where everything is heading. We're seeing the research and the capabilities all going in that direction. So somebody's going to be building the stuff out correctly, effectively. I don't know who, but the idea is coming into focus. Here's Leopold Aschenbrenner, his paper Situational Awareness, talking about the intelligence explosion. He believes that somewhere in 2027, that's just an estimate, but somewhere around that time, AI will get good at carrying out automated research into AI, right? So the best AI research teams will be AI assisted or fully AI automated, right? And the important thing here is we don't need to automate everything, just AI research. A common objection to transformative impacts of AGI is it would be hard for AI to do everything. But that might be missing the point, because what it's saying is it will be hard for humans to get AI to do everything. But what if we just automate AI research, right? So AI improves itself, right? The job of an AI researcher is fairly straightforward. Read machine learning literature or come up with new questions or ideas, implement experiments, test those ideas, interpret the results, and repeat. This seems squarely in the domain where simple extrapolations of current AI capabilities. So just if you kind of project into the future, certainly AI is going to get there. And he believes by the end of 2027. Once you have a good AI researcher, you'd be able to run millions of copies of it. You can run 100 million human research equivalents running day and night. And of course, automated AI research will have enormous advantages over human researchers. They'll be able to read every single machine learning paper ever written, think deeply about every single previous experiment that was ever run, learn in parallel from each of their copies. They'll easily be able to write millions of lines of complex code, keep the entire code base in context, and spend the equivalent of human decades checking and rechecking every line of code for bugs and optimizations, right? So that's these two steps, for example, for Factory AI, right? Testing, producing unit testing, going through, code block by code block and unit testing every single thing very thoroughly, coming up with some crazy things to plug in there, right? What if you add infinite numbers or other weird numbers or whatever, right? Then you have the review, continuous integration, self-healing, bug fixing. Again, they're going to summarize everything. So you will have documentation that is far better than anything we've seen as humans. It'll be up to date. It'll be robust. It'll be complete, or as complete as it can possibly be. You won't have to individually train up each automated AI researcher. Instead, you just train one, and then you make replicas of that one. You don't have to worry about politics, cultural acclamations, or anything of the sort. They will have much more efficient collaboration and coordination compared to human researchers. And perhaps more importantly, when the new models come out, meaning that as we go from GPT-4 to 5 to 6 to 7, this entire system, everything that it's doing kind of jumps forward. As the systems get smarter and better and faster, everything improves. So as we build the architecture of GPT-4 or 5 and improve this architecture and how it works, then the next generation model comes out, it just plugs in and everything jumps to the next level. GPT-2 to GPT-4, that jump, that progress was the same as going from a preschooler to a smart high schooler. What is the equivalent jump of the same magnitude to the next thing, right? So this was 5 orders of magnitude from GPT-2 to GPT-4. What's another 5? Where does that take us? If we're here, plus 5, where do we land? There's a lot of talk right now about whether or not the software developing jobs are going away. Are the people that are doing software development, are they going to be out of a job once stuff like this starts kind of flooding into the market. I've been meaning to do a whole video diving deep into this. I mean, the reality is, I don't know, no one knows, but I think the few things that are almost guaranteed to happen is, one, I think in the past, really good programmers were like rock stars, right? Their ability to write out code line by line was in great demand. The great ones were truly great at that. They were artists of a sort. I think the power of one person writing code line by line will decrease a little bit. In other words, the lead guitarist coming up and doing a guitar solo, that won't be as much of a thing. I think more and more we're moving towards the top of the line software engineer being more of an orchestra conductor. They might be great at any particular instrument or maybe not, but certainly they have to have some familiarity with it. They have to understand what makes it work, what makes it sound good, kind of what goes into it, what you can get out of it. But their job isn't to sit there and pluck every string and hit every note, etc. Their job is to make sure that everyone's doing their job, that everything's outputting what it's supposed to output correctly. And their job is more to get that top high-level output from everything. But I don't think that means they know less than the actual performers. I don't think it means they work less hard. I think in order to be an excellent software engineer 10, 20 years from now, you still have to be very smart and logical and make good decisions. You have to know the code, the environments, the architecture, the everything. I don't think that's going away anytime soon, but I do think you're going to be doing less and less of actual typing in the code and running the tests and writing comments and documentations and etc. Even before AI, that was slowly kind of getting, you could say maybe a little bit more automated. You had a little bit more keyboard shortcuts, suggested completions, more stuff available online. AI is just the natural continuation of that. And the second thing that I think is going to change is there's going to be a lot more natural language in coding. Natural language means, basic English instead of a coding language like Python. We're already seeing more and more of that, even on the stuff that we cover on this channel, where we're seeing more and more prompting of AI models, right? You might write something in Python and get to the point where you're initiating, let's say, GPT-4o to do something, and you start by telling it, you are a helpful assistant here to help me code. Here are some things that you need to know to be better at your job, etc. And that kind of is its own language that we have to get used to. So, for example, currently one thing that I saw repeatedly is that if you ask a model to grade something, you're going to use LLMs as a judge, so to speak, where you're asking it to grade the output. Let's say you give it a task like rate something out of 100 points. All right, so 90 points out of 100, 80 points out of 100, etc. The results aren't that good. And that might improve as the models improve, but in general, you're not getting the best outputs possible. Some models even tend to throw out, round numbers like 90, 80, 70, sometimes 75. Like they tend to kind of predict certain numbers above the others. It just doesn't work too well. But in some other papers, I think Microsoft had a paper where they really managed to improve this by, for example, let's say we have a scale out of 5, and instead of saying just say, X out of 5, whatever your rating is, they'll say, go through this output, and if it has the following elements, if it has at least these things, then you give it 1 point. Then go through it again, and if it has these, kind of higher level elements, then give it another point. And again, until it gets a maximum of 5 points. Sorry, I had this off screen, but the point is it goes through and it's like, is it at least this good? Yes, 1 point. Is it at least this good? Yes, 2 points. And so it basically goes through over that output 5 times in this case, but you can make it as many times as you want, checking it every single time for a specific thing. So if the grammar is good, give it a point. If the argument is logical, give it a point. If it's simple to read, give it a point. Go through it 5 times over the same sort of output and grade it. And that has been shown, at least in some of the papers that we saw here, to be really, really good, because you're not asking it to throw out a random number. You're asking it, if it has this specific sign of quality, then give it 1, otherwise 0. And that approach is much more effective. So I think in the future, people working with software engineering, I think AI will become much more a part of it, no matter what industry you're in, whether you're in AI or not. But you're going to be dealing with code that is very like unforgiving and cold and logical and has to be quote unquote right. But you're also dealing with large language models where there's a little bit more room for ambiguity, where there's more gray area, where knowing little tricks like this will greatly improve your results. Which again brings me to that orchestra conductor type of visual where you're trying to get the best out of the strings, the percussions, the whatever. Each one has its own little twist, its own little quirk. And your job is to just get the best possible output, the best possible outcome of all of that collectively. Anyways, that's just my 2 cents. Let me know if you agree in the comments. This is Wes Roth, and thank you for watching.